Good morning, everyone. My name is David Fischer, Lathe Product Specialist at Okuma America. Today we're going to talk about Okuma's Laser EX laser hybrid multitasking machines. These machines bring a new level of process integration by combining not just turning and machining, but also laser hardening and laser metal deposition, as well as grinding. First, we'll talk about laser hybrid technology in general and some of the basics of how it works and what makes it different from other laser additive technologies. Then we will talk about some application examples to see where laser additive might fit into your production process. And finally, we will talk about Okuma's laser hybrid system. Okuma introduced the Laser EX machines in 2016. Two machines were introduced at that time, the MU6300, demonstrating laser metal deposition technology, and a Multus U4000 multitasking machine demonstrating laser hardening technology. So now process integration can include subtractive machining processes plus additive for building structure and performing material cladding. So here I want to compare the advantages and disadvantages of both subtractive and additive. Subtractive has the advantage with accuracy, surface finish, and cycle time, whereas additive has the advantage with material consumption, material freedom, and geometric freedom. By combining these into a single hybrid machine, we can take advantage of the benefits of both to achieve far greater capability. Let's start by talking about two of the most common additive platforms, powder bed and hybrid. Each has its advantages, but we feel that the hybrid platform will have the widest application since it has the most flexibility. Powder bed will provide a better finish than hybrid due to its smaller powder size and smaller layers. This typically is not a problem for hybrid machines, however, since we have built-in subtractive capability and can machine anything requiring a fine finish. Typically, powder bed has a somewhat restricted work envelope. Powder bed is slower at material layup due to its lower material deposition rates. It is restricted to a single material and is also restricted to a 2D print layup. Hybrid typically generates coarser surface finishes, but as I stated earlier, this is usually not a problem since we can machine those surfaces. Hybrid uses a larger powder size, so it is less of a potential health hazard. Hybrid's working range is limited by the range of the machine tool. Hybrid provides much higher deposition rates, it permits the mixing of materials, and hybrid can do 3D print layups. Let's take a brief look at the technology behind this system. Probably the most common laser technology out there is the fiber type laser. This is primarily due to a lower cost and its being a good single-purpose laser. Okuma, however, has chosen a disc laser based on 6th generation Trumpf disc laser technology. This system provides the best in beam quality, stability, and durability over a wide power range. It also provides the greatest flexibility, far greater than fiber type lasers. Now for a quick overview of the laser metal deposition process. First we have the workpiece, and then above that we have the nozzle with the laser beam itself. Then we have the shielding gas to maintain a quality process, as well as the powder and the carrier gas. This generates the melt pool resulting in the deposited material and the dilution zone, all of which are able to be controlled, giving us a high quality and repeatable process. Beam profile is another area that has to be considered. When discussing laser beam quality, a high-quality beam is a reference to the shape of the beam. A high-quality beam is the typical Gaussian beam, however this is really useful primarily just for cutting. To do other operations, we do not want this high-quality beam, so it's modified to be more useful. One of the most useful shapes is the flat-top beam. This beam provides a wide area of similar energy and works quite well for cladding and laser metal deposition. The other common shape is the donut beam shape. This is generally used in laser welding with the first high energy spike applying the weld. Then it cools slightly before the second high energy spike smooths out the weld. In addition to beam profile, there is also the shape of the beam focus area. For Okuma's Laser EX system, we use two shapes. For laser metal deposition, we use a round spot. The size and power are fully controllable from the CNC program. For laser hardening, we use a line-type beam shape. Note that laser hardening is only possible on carbon steel. The overall system is composed of many components. The machine is modified to handle both the laser and metal powder. All windows are laser safe and the machine is sealed to contain all laser emissions with sensors throughout to make sure the work envelope is never compromised. Containment of the powder and protection of the machine slideways are also provided for. The second major component is the 4 kilowatt Trumpf disc laser oscillator. The disc laser is the most flexible and reliable system currently available when dealing with a wide power range. The optical unit as well as the powder nozzles are mounted inside the machine and protected during cutting operations so coolant can be used during machining. The camera monitor permits better control of the process and makes setup easier. Powder conveyors are available in 2 and 4 hopper configurations. Switching powders is easily done in the NC program. The required chiller and transformer are provided along with the gas bottles for powder delivery and shielding gas. And finally, proper powder handling and cleanup devices are included as are mist and dust collection, providing a safe work environment. The laser unit can supply 2, 4, or 6 machines, and the number of connections determines the cabinet size. Alternatively, the cabinet can accommodate future growth by specifying a 2-connection laser in a 4 or 6 connection cabinet. The additional connections can be added later. The laser unit can power both laser hardening and laser metal deposition. With this type of system, the laser is available on first-come, first-served basis. Only one machine can use the laser at a time. Typically, a laser is dedicated to a single machine. However, with hybrid operations, the laser can power multiple machines since they do not require the laser 100% of the time. For instance, if 20% of the cycle time of each machine is dedicated to laser metal deposition, then theoretically one laser can supply 4 machines, significantly reducing costs. Laser metal deposition provides many advantages over more traditional methods. Since the laser provides highly focused energy, the overall thermal load is reduced, as is part distortion. It is a very controlled process that can easily be fine-tuned by changing process parameters to provide the proper dilution zone. It creates a repeatable process and automates it. It provides high powder efficiency once the process is dialed in. It creates near net shaped structures to minimize final machining. It provides a superior metallurgical bond compared to thermal spray. No surface preparation is necessary, and building 3D structures is possible. Possible applications are structure generation to build complex parts with less material removal, adding structure to parts for customization, adding structure to parts for reinforcement, adding metal cladding to functional surfaces including wear and corrosion resistance, and finally, component part repair. Here are some examples. So from left to right, adding a boss to a part saves time and material compared with having to start with a larger piece of material and machining it away to create it. Die mold repair can be simplified by machining away any damaged area, laying in new material, and then machining it back to size, all on a single machine. Shaft repair can be an integrated process, machining away the worn areas, laying up new material, and machining it back to size. Cladding is probably the most common use of laser metal deposition. Placing high-grade materials on a base metal can provide a high-performance component with reduced part distortion, control of the dilution zone, and a near-net shape to minimize machining. Cladding can be used to provide improved function in specific locations with a lower-cost base material. This can provide improved performance while reducing overall cost. Applying hard material on blades used in agricultural applications provides superior wear resistance and therefore a superior product for minimal cost. The improved component life means less downtime in the field for the end user at a critical time of the harvest season. This can be the difference between getting the crops in the barn in time or losing it to bad weather. Applying hard material to downhole stabilizers or other parts requiring wear and corrosion resistance saves time and money. Having the ability to machine and clad large and/or long parts without having to move them between multiple machines is far more efficient than multiple part handlings. Safer too. Here we have a medical part that uses a stellite coating for its cutting edge. The original process applied the stellite manually. As you can see, this consumed a lot more material than the laser metal deposition process. This also meant that it required the removal of all excess material, adding useless cost to the parts. The advantages here are reduction of coating time, reduction of material usage and cost, improved consistency of material application, and reduced post-processing time. Laser metal deposition can be used to repair component parts, especially parts for heavy industry and transportation. Typically, these parts have a long service life, and when they are worn, quite often it is difficult to obtain replacements, so repair is mandatory. Laser metal deposition provides a very repeatable build-up process that can then be machined to spec. It is also possible to lay up better materials for increased service life, surpassing that of the original part. I want to talk a little more about geometric freedom. Here we have a demo part that shows a mesh pattern that was laid up using a high-definition nozzle. This demonstrates the tremendous freedom we have when using laser metal deposition, in that not only can we switch between materials based on varying part requirements at various locations, but we can also change the physical makeup of the part. If I need to lighten a part in a specific location, I can change from solid material to a mesh or honeycomb build. I can use this method to slow thermal transfer as well. In this video, we begin by showing the MU6300 performing laser metal deposition. To start, we use the gauging system to locate the build surfaces prior to beginning the deposition process. Once the surface is set, the laser is activated and the process begins. To minimize thermal stress, we add material to the blades one pass at a time. Once the build is complete, the laser is safely retracted and the feature can be machined with or without coolant. Next, we can look at a die mold part that needs repair. After machining away the worn or damaged area, the laser system can lay up new material in preparation for repair. The 5-axis machining capabilities of the MU6300 machining center can then be used to repair the part and place it back into production. Now let's take a look at some heavy cladding on the Multus U4000. For this operation, we are using the high-capacity nozzle to quickly lay down corrosion-resistant material, integrating processes to complete the part in a single operation. In pursuit of the development of this technology, Okuma has invested in a laser laboratory to assist customers with feasibility studies as well as process testing and development. The machines can include both Multus and MU platforms to handle a wide range of parts in many different configurations. So that's a brief overview of Okuma's Laser EX technology. Obviously, there's a lot more depth to this topic than we can cover in this brief presentation, but we would be happy to answer any questions you might have. Please contact your Okuma distributor for more information or to discuss your particular application.